Hello, my name is Mitchell Volz, and I was assigned to do problem 5 of problem 5, which was question 22 of section 1.4. And our job here was to find the explicit particular solutions of the initial value problems. And so our original equation was this, with the condition that y of 1 equals negative 3. So the first thing I did was kind of turn this into a separable differential equation, which, as you can see, I just, took out the y there. Then we separated the variables to their respective sides, which gave me 1 over y dy equals 4 times x to the third minus 1, and all of that is times dx. From there, we simply integrate and integrate both sides. And, kind of each step here is kind of simplifying it through. I'm not sure how in-depth I need to be for each one, but, just turn these into two separate equations. Got ln of y there to integration. Then we have 4 times x to the fourth over 4 minus x plus ln of c. Of course, they cancel out. And I wasn't sure what I needed to include, so I kind of used these two equations to get this. And continuing on, all this is more algebra here, just simplifying and combining the fours. They cancel out, of course. Then I moved ln of c to the opposite side, and since, of course, when you subtract the ln's, they ended up being divided by each other. Or sorry, the second is divided by the first. And I actually could not take this picture, or could not take my problem picture in one picture, so I will go to the second half here. And as you can see, we left off right here. And so then we end up with this equation. And from here, we take the exponential of both sides. So, you'd either put ESP, or I always use E just because that's just my preference. And so we have e to the power of ln times, and it's a little bit hazy here. Sorry, I don't have the best phone for this, but this is y over c then, of course. And then you have equals e to the power of x to the fourth power minus x. And because e and ln, e to the power of ln kind of cancels out, that you end up with y over c equals e to the, it's difficult for me to say each time, so if it's the same one, I'm just not going to say it. And then from there, we just get c to the other side, so it's set as a function of y. And there we have the general solution right here. And from here, since we need to find the particular solution, we have to solve for c. And to find c, we have the original condition at the beginning, which I wrote conveniently down right here, of y of 1 equals negative 3. So we fill in x equals 1, and, it kind of simplifies out, all the x to the fourth power is now 1 to the fourth power. That 1 minus 1 is 0. So you have c times 1. So it'd be y of 1 equals c. And then fill in y of 1 equals negative 3, and c equals negative 3. Now plug that into the equation right here, and we come up with our final particular solution of y of x equals negative 3 times e to the power of x to the fourth minus x. My name is Mitchell Volz, and I suppose, that I performed this VP as I should have, and I guess I will talk to you the next time I have to do this.